we are going to define our own modules. Okay, now why do we need, why do we need to create modules? Okay, yesterday we saw, okay, that there are different modules are there. Math module is there, random module, OS module, NumPy module. Okay, your pandas module, SciPy module, your Seaborn module. There are literally thousands and thousands of modules are present there. Okay, because based on different applications. All of them are basically used in different applications. Some of them are used in machine learning. Some of them are used in data science. Some of them are used in data analysis. Some of them are used in your cryptography. Some of them are used in game development. Okay, some of them are used in website development. Okay, so similarly, there are multiple modules for different applications, for different sectors, for different domains completely. Okay, now we're going to create a simple module right now. I'm going to show you how to create your own module. So for that, let's do one thing. Whichever folder you're working in, just go there, okay, and here click on new and create a txt file. Okay, so here you can see an empty txt file will get created. Okay, now I'm going to rename this particular file in .py format. Suppose I can write here maybe something .py. Remember class that we have to give a name. Okay, here what we are doing, we are creating a module. What is a module? Module is a separate file containing a set of functions that we want to include in our code, in our main code. So here we are creating a module. So here whatever name we will give will become the name of the module. Okay, first thing. Second thing is that whenever we are giving names to the module, we have to make sure that the name that we are giving from our end should not clash with any of the inbuilt module. Suppose if I name this file as math.py. So what will happen? Math.py is also, it is an inbuilt module. Okay, and we are making the same from our end also. So there will be a clash between them. So to be on the safer side, you can put them like, you can write here math1.py. Okay, or you can enter some keyword. Okay, maybe let's say key math.py. Okay, or suppose what I do, I write here check math.py. Okay, similarly you can create. So right now class I am creating checksum.py. Okay, so here you can see checksum.py is basically becomes a Python file. Okay, in this class, in this module, we will create a function, simply def add. Let's say I will mention two variables here, a comma b, two arguments basically. Okay, and then we will do something with these arguments. Let's say we will write here c is equal to a plus b. We will create a variable here also. Let's say f is equal to, let's create a list for now, 1, 3, 5, 7, 9. This is a list. Let us create another function here, def sub print. Now you can see class, I have saved this file. Okay, we are saving this file here. So as soon as you save the file, there will be a tick mark here. In the top, you can see there is a tick mark. So where tick mark means that the file is saved. Now class, what we are going to do? Let me separate this. Okay, so this is our main code. This is our main code class, and here in the left hand side, this is your module. Now here you can see class, both of them are present in the same folder. Main code also and your module name also, both of them present in the same folder. So what we can do in this case, we can directly write here import check sum code. So you can see it has successfully imported. Now I can write here add. We are returning some value, so I will create a variable also, z is equal to, let's say I am writing equal to 12, y is equal to 6. I can write here z is equal to any variable at all, p is equal to add x comma y. So what will happen, class? Here, in this case, X will go to A, okay, and Y will go to B. Okay, they will be added here. They will be added, and the output will be stored in C variable, and the C variable, the data inside the C variable is returned. So C will come to your C will come to P. Okay, so this is how the whole thing works. So I'm going to call this code, class. Okay, it is saying name add is not defined. So it is saying name add is not defined. Why? Because here you can see, class, add function is not present in the main code. This we have already covered in the last session. Add is present in the checksum file. So we need to mention here checksum. And now checksum is a big name, so I can write here import checksum as cs maybe, and here I can write cs.add. So you can see now the code is running. So if you write here print t, it will show us 18. That means 12 plus 6 done here. Similarly, if I write here cs.f, it will give me the whole list. cs.f of 0, it will give me 1. cs.f of 2, 5. Okay, so you can see it is working in the same manner. Similarly, cs.sub, here there is no argument, so I can simply run this code. It will print hello. So this is how your code works in case of modules. Okay, so that is the only thing that was left in modules. Okay, rest all we have already covered. Okay, everything, your from statement, your as statement, okay, your from checksum import star, okay, everything can be done. Class, everything can be done. Okay, now class, after this we will move on to next topic. Next topic that we are going to cover is your file handling. So one thing in modules, always remember that the module that you are creating, that you are importing in your code, either should be present in the same folder as the main code, or it should be present in the root folder wherever your Python is installed in your computer. So either in the root folder or in the same folder as the Python, as the main code where you are importing it. Okay, that is important. Rest all is totally up to you. Next topic that we are going to start is class file handling. So what is handling? What is file handling? File handling refers to the handling of data files present in the system using a Python program. So suppose, let's say class, suppose I have some file present in my system. Okay, I will create a txt file here for now. Okay, maybe let's say maybe. Okay, so here you can see this is your maybe.txt. Here you can see maybe.txt. This is the whole file name. So what you will do, class, you will open this code here. We have to open this file. I will enter something here. Let's say hi there, how are you? Okay, this is our data that we have mentioned. I will save the file. I will close the file. Now suppose if I want to read this data in the main code, so I can write here f is equal to open. Here I have to mention the file name maybe.txt. Okay, and after it I have to mention access mode. Access mode, that means in which mode I want to open the file in. So there are three modes majorly, guys. Here in case of this file, there is your here there are three types of access modes available. One is your read mode, second is your write mode, third is your append mode. These three modes are available, class. So here what we are going to do, we are going to open the file in read mode first. So we'll write here R. So as soon as we run this code, here you can see it is saying R in quotes. Okay, it is working fine. So you can see F is your maybe.txt file opened in R mode with this encoding. Now suppose if I want to read the contents of the file, so what I can do, I can write here R dot f dot read. Okay, so if you simply write f dot read, so whatever contents are there in the whole file will get printed on our screen if we use f dot read. Okay, if we don't pass any argument to the read function, but suppose you want to read some specific characters only, so you can mention some number. F dot read 5. That means I want to read 5 characters from the current file pointer position. So current file pointer position will, remember class, whenever you open a file in R mode, the file pointer position will be present in the beginning of the file. So here you can see it is starting from the beginning of the file and going till end. Now if I want to change the file pointer, what is file pointer? Okay, so here you can see in this case, okay, here you can see there is a blinking bar. Okay, so this blinking bar is called as a file pointer. So wherever it is present, it will either delete or save the data at that location only. Okay, so now there is one way here. Suppose I want to change the position of the file pointer. So I have to write here f dot seek to see the current position of the file pointer. I will write f dot tell, it will give me 22. That is the current position. If I write here f dot seek, and I want it at 0th position, that means with respect to the beginning of the file, 0th position. And then if I again tell, see current position is 0. Now if I start reading, f dot read, f dot read, suppose if I enter here 5. So here you can see it is just reading the first 5 characters from the file. Only the first 5 characters including space. Okay. Now if I write here f dot tell, it will show me 5 because the file started from 0th position. Then we read 5 characters. Now the current position of the file pointer is 5. As soon as you write class and as soon as you read, okay, both the operations are dependent on the file pointer. As it continues reading or writing, it will also, your code will also change the file pointer in the file particular. Okay, and in the end, in this R mode, you cannot write. Okay, if you try to do it, it will throw an error. Okay, suppose I am writing something, so it will throw an error, unsupported operation not writable. Okay, now class, once you're done with everything, reading and writing everything, you have to close the file, f dot close. File is closed now. So whatever operations you want to do, read or write, cannot be done unless and until you open the file again. Okay, so now let us see one thing with read or write also. Okay, suppose I am write mode also. I am opening a file in write mode. Okay, here or append mode also is there. So I will open this file here in write mode. Okay, W. Okay, so here you can see now class, in this case, what happens? Earlier there was some data in maybe.txt, but now if I open it, it is empty. Because what happens in case of write mode, whatever file you're trying to write should be newly made. Okay, so if the file is already present, it will overwrite it. If the file is not present, it will open it to write something. But in case of, if the file is not present, it will create a new file and then it will open it to write something. But in case of read mode, the file that we are trying to open should already be there in the computer. If it is not there in the computer, okay, while you are reading it, okay, then at that time it will throw an error. Okay, so we first create the file manually in case of read mode and then open the file. Okay, so open maybe.w. So if I write something here, you can see right now maybe.txt is empty, but I am writing here fw.write. Hello. Okay, if I run this code, working fine. If I go to fw.close, now it is important to close the file every time you like do some major difference in the file. Okay, now I am going to close this file. Now if I run this code class, if I run this file, here you can see hello how has been written here. Earlier it was empty. Earlier it was empty, but now hello hi is written here in this particular file. So open, close, write, read, and seek, tell. These 6 operations. There are other operations as well, but you won't be using them majorly. Okay, the majority of the modules that we have covered are basically used a lot. Okay, so now let's continue class. Okay, there is another mode called as append mode. Okay, see, in read mode, the file that we're trying to open should already be there and we can read from the file. In W mode, it is going to create a new file always. Okay, if the file is present, then it will overwrite and create a new file. If the file is not present, okay, then it will create a new file and then open it to whatever you want to do with the file. Okay, but there is another mode class called as append mode. In append mode, when you're trying to open a file, okay, if the file is already there, that you're trying to open, then it will open the same file. Okay, and whatever you will write, okay, will be written after the contents of the file. Okay, in append mode. Okay, but if you're trying to open a file which is not present in append mode, it will create a new file and then open it. Okay, so this is your append mode. Okay, so for append mode, you can write in place of W, you can write A. So read mode, W mode, and read mode, write mode, and append mode. These 3 modes are there. Okay, read mode for reading, write mode for writing, AF mode for W mode for writing in an empty file, and your append mode for writing in an existing file. Methods are going to be same. Your open, close, read, write, tag, this tell and see. These methods are going to be same class. Okay, so this is majorly about your file handling. We will cover some more part of the file handling later on. Okay, next topic that we need to cover here is your class OOPS. Okay, next topic that we need to cover is OOPS. Just give me a minute. Next topic is OOPS. It means object C class. OOPS means object oriented programming. OOPS means object oriented programming. S also means subsystem. Okay. Now, one of the popular approaches to solve a programming language is by creating objects. Let us understand what is OOPS, how it does it work. Okay, OOPS is a very major topic class. Okay, because in Python specifically, okay, because in your whole Python, the whole core of Python, everything that we use is basically created using OOPS only. Okay, so that is why it is an important topic here. Now, what exactly is OOPS class? Why do we use it? See, what happens whenever we are coding something. So what exactly we are doing? We are basically taking the real life problems, okay, real life scenarios, okay, and solving them using coding, such as your automation, okay, to do some automation, create a file, okay, execute, modify a file, okay, work with the database, create a game, multiple things that can be that we need. Basically, all of them are required in real life, right? Now, in real life, we consider everything as an object. Everything, laptop is an object, mouse is an object, your table, fan, light, okay, your chair, your maybe phone, okay, maybe your pen, paper, okay, your whatever is there, okay, with you, okay, it is basically an object. Everything is an object. So when we consider each and every identifier as an object inside your code, then that means that we are going to use object oriented programming. Okay, basically it is an architecture, how it is basically a structure of programming, how we are structuring our own code. Okay, so let's continue class. So one of the popular approaches to solve a programming problem is by creating objects. This is known as object oriented programming. For example, an object has two characteristics. It has some attributes, it has some behaviors. For example, let's say there is a parrot, okay, and parrot is an object. Now name, age, color, okay, all these things, name, age, color, your height, weight, okay, your maybe the color of beak, color of let's say hair, color of body, okay, so multiple things, these are all attributes, okay, of an object, okay, and behavior is basically what that particular object can do. Suppose if the parrot says that parrot can sing, or parrot can walk, or parrot can fly, these are all behaviors, or in other words we call them as methods. All of them are called as methods. All the behaviors are called as methods of an object, okay, and all the objects, okay, having the same design come under a same class. Let me explain this class in detail. What is class? Okay, class is a blueprint that defines the variables and the methods common to all objects of a certain kind. Common to all objects of a certain kind. Suppose I am creating a building. Okay, maybe I'm building a building. Suppose, okay, building a house maybe. Okay, so first what I will do, I will first create a blueprint. Okay, and by using that blueprint, I can create a single house also. I can create, let's say, 4 houses also. I can create 100 houses also. Now, that blueprint that we have created is called as a class here. In coding, we call it as a class, inside the class, we define all the methods, okay, what that particular class can do. All the methods of that class, okay, all the variables of that class. We will define all these things in a class. Second thing is an object. Object is the actual implementation of that blueprint, or also called as instance of the class. Object of the class, instance of the class, same thing. Okay. But suppose if I'm creating a building out of a blueprint, then that building will be called as an object, and that blueprint will be called as a class. Okay. Suppose I'm creating, let's say I am creating maybe a car. Okay, so for car, we will first design it completely. Once the design is complete, that is your class part. Okay, inside the class, there can be multiple objects. Okay, suppose car number 1, car number 2, car number 3. Okay, so all of them can be multiple objects of the same class. Okay, now third point, leave the third point for now. Fourth point, class variables are variables whose value is assigned in the class. Okay. Class variables are those variables whose value is assigned in the class. So what I'm going to do, I'm going to create a class first. Okay, in Python here. Okay, so we'll write here class. So let us create a class called as human. Okay, and inside here class, you will create class variables. Let's say I'm creating a variable called as, let's say, hair color, for example. Hair color is equal to, I'm writing the value of this is black. So what is this called class? This is called as a class variable. Okay. Then we're going to create some methods. I've write here def. Let's say human being can walk. So we will write here walk. Inside this we'll write self. I will explain why self is written. And then print I can walk. We'll create another method. Let's say def maybe run. Okay. Self. We have created a class here. Now what we are going to do, we are going to call we are going to create objects from this class. Here we have designed a blueprint. That means a particular object of the human class. All the objects of the human class will have hair color as black, and all of them can work also, all of them can run also. Okay, so this is what happens in your class. So I will write here, let's say I am creating an object called as, okay, let's say S1, person1, let's say person1, okay, is equal to human. That's it. So your class has been created. Now what we are going to do, class, we are going to associate the functions, all the definitions, all the methods, all the operations along with your code. How do we do that? We can write here p1. If I write here p1 dot here c, it will tell me that okay, it is color black. So here you can see p1 dot here c, it is giving us black. Second thing, if I write p1 dot walk, fine, I can walk. Let us set another variable here, another object here, p2 is equal to human. As soon as we run this code, here you can see p2, an object of human class has been created. Now we can write here p2 dot here c. You can see p2 also has here black hair color. Okay, your pink also has pink has your pink black color. Yes. Okay, pink or whatever, like we can define multiple hair colors depending on multiple classes. Right now we have defined a single class, only human class. So all the objects of that class are going to have black color only. Okay, whatever color we have defined. Okay, updates can be as many as possible. P1 we have defined, P2 I have defined. There are literally crores and arabs of functions. Okay, so how does this work? First thing, P2 is equal to P2 dot here see black variable. Next thing, class, suppose if I want to, like if I want to see if P2 can work or not, so I can write P2 dot work. So here you can see it is saying P2 I can run. That means P2 can run. Here I will write P2 dot okay, suppose I want to create a, okay, I want to create a new information. I want to create a new attribute here in the story. So here I can write here p2 dot attribute name. Suppose I can write here age of the person is equal to, I can write here 32. So if I run this code, you can see p2 dot age is there, but p1 dot age is not there because no data got saved to your p2 object. Okay, in p1 it is showing this is not defined because we have not defined, we have not sent name variable as normal. Okay, now class, here you can see in the class, inside the class there are three things. Okay, there is a class variable and there are two methods. Now whenever you want to run anything, we are able to specifically call that particular method or particular class variable, whichever you want to work on. Okay, if you want to work on here c, then we can write here, let's say h1 dot here c, it will work. H1 dot run, it will also work. So now this particular concept is called as abstraction. Okay, this is called as an abstraction. Okay, so if you're basically taking some particular data from the whole class, that is called as an abstraction class. Let's move forward. Next is your constructor and destructor. Okay, now what is the meaning of constructor? Let us see. Okay, so in this case, class, you can see I stopped screen share, right? In this case class, here you can see we're creating a class here. Okay, and inside that class we're creating a constructor. Now what is the meaning of constructor? Constructor is basically a method which automatically runs as soon as a particular object of the class is created. Constructor, see, constructor is run as soon as an object of the class is instantiated. Okay, the method is useful to do any initialization you want to do with your object. This is what happens in your constructor. So let me show you class.
Oh, sir.
Yes, are you asking
Sir,
something? Yes.
sir, what is self that is used in the
Self.
method?
Okay. So see, self is what happens when you're writing here p1 equal to human. So p1 is an object of the human class, right?
Yes, sir.
Now when we write p1 dot here c, it is working. Suppose I create a random variable. Suppose I create a random variable l is equal to. I'm creating a list here. Okay, let's say I will write 1, 2, 3. This I have done. Now in this case, suppose if I write here L dot here C. So should it work? Should
No.
it work? No, because L is a separate object altogether. Separate object. Whenever you want to create an object, we have to write it like this. Okay, object name, variable name is equal to that name of the class. This is how we write it. Okay, here we have not mentioned anything related to your hair color. So if I run this code, it is throwing an error, attribute error. Hey, list object has no attribute here C. So now what is the meaning of this class? Here C, because the list, because the L object is not linked to your class in any way, that is why it is throwing an error. Okay, and why it is not linked? Because we have not called the object anywhere while creating it. Okay, we should have written L is equal to human, then it will work, otherwise it will not work. Why? Because of the use of self. Okay, what happens class in case of self? Whenever you are writing p1 dot here c, let's say, so here c will get linked to p1. Okay, because and p1 is linked to the human class, so human class is linked to p1. Since both of them are linked to the p1, that is why here c can work on all the objects, of your parent class. This is what happens in here, this linking. Now where is self used? Self is basically used to link the object when you write now, when you create p1 equal to human. Okay, so what happens in this case, your p1 will get linked to the human class because of the self in the bucket. Okay, so your method, whatever you want to do, okay, is matched to the, is basically connected to your walk class, your human class basically. Okay, and all the objects of the human class will get connected to the human class and they can also do the same task. That is why it is called as a self. Okay, is basically called as a binder, which binds the objects with its class. Clear class everyone?
Excuse me, sir.
Yes.
Then if we will not write the self, then it will not work, sir.
If you don't write self, it will throw an error.
Okay, then we will write self as argument there.
Self should always be there, yes. Inside, whenever creating functions, remember class, when you create functions inside class, then they are called as methods, first thing. Second thing, and when you're creating methods, in methods you have to always mention self, because to bind everything together.
Okay. Then self is a keyword, sir.
Self is what?
So then for every argument we have to write only self.
For every method, self. Okay, if you,
Yes, sir.
and
For
self
every
is not
method
even
we have to write
self only, huh? But if there is an argument also involved, if there is some argument involved, then you can write here self. Let's say there is an argument x, so you can write here self comma x. So here x will be called as an argument. Self is just a parameter that you are passing to the method. That's it. Self
okay,
is not argument.
okay, sir. Thank you, sir.
Now let's continue. Okay, so I was talking about constructor. Okay, so constructor is run as soon as an object of a class is instantiated. Okay, so what I will do, I will take this same human class, create it here, and I will mention, I will create here a method using init. When you use double underscore, init double underscore, okay, self. So init is basically automatically, you have to use init only, remember class, for a constructor. So init is a constructor here. Okay, constructor here. I will maybe take an argument maybe here, name. Okay, so let us without name for now. I will print here, print creating object. Now here you can see this is a particular, this is a function. This is a function here class. We can see this is a your init method. Okay, and this is your normal method. Okay, or we can call as function also, same. Now I will run this code. Now I'm going to create an object. As here you can see class, earlier when I was writing p1 equal to human, we were getting nothing as an output. But when I write here p1 equal to human, what will happen? We will get creating object as an output. Why? Because as soon as an object of a particular class is created, so the constructor of that class will also get created along with it. Constructor will be called automatically, not created, sorry. Constructor will also be called along with it. See, suppose if I write, I will make another object. Okay, so here also it will work. Okay, so suppose we can write here, let's say I'm creating a class variable. Now remember that class variables are basically common for all the objects. If I write here p1 dot here c, I showed you earlier also, it's same thing. p2 dot here c also same thing. Okay, if I write here human dot here c, we can literally call class variables using your class names also. Human is a class name. Human is the name of the class C. Okay, so human dot here C will also give us same data. I'm going to create another variable here class. Let's say count equal to 0. Initially count equal to 0, and whenever the constructor is called, I'm going to increment this value. I'm going to write here human dot here C, okay, plus equal to 1. This is how you call a class variable. You cannot simply write here C plus equal to 1. Sorry, this should be count. You cannot write count is equal to count plus equal to 1. You have to mention completely human dot count plus equal to 1. Okay, so I'm running this code again. Okay, and then creating the object here, p1 equal to human, p2 equal to human. Okay, so I have created two objects. So that means your count variable must have incremented two times. So if I write here human dot count, it will give me 2. If I write here p1 dot count, it will also give me 2. p2 dot count will also give me 2. Suppose I am creating another object, p3 equal to human. So that means this particular method was called again, and the value was 2. For the count, the value was 2. Now it should be incremented to 3. If I write here p3 dot count, it will give me 3. Human dot count 3. So this is a class variable. Here C and count, both of them are class variable. They are going to be constant for each and every object. Okay. Next thing is your class instance variable. Object and instance are same thing. When you write p1 equal to human, that means you are creating an instance here. We are creating an instance here, creating an instance of the human class. Now we are going to create instance variable. So let's say I'm creating a variable name. Okay, name. So let's run this side. Now here class, one thing. Okay, here there is one thing that you need to remember. In this case, I told you that constructor is called whenever we create an object. So whatever variable you mention here in the init method, you have to give it during the object creation only. If I write here p1 is equal to human, okay, then in the parenthesis I have to give the name. I have to give some data because earlier because otherwise it will throw an error that init is missing one required position argument name. So we have to mention something here. Suppose I mention here Harshil. Let's say for now. You can see if I write here p1 dot. Sorry, we have to use it inside also. Self dot name. Okay, for instance variables we use self. For class variables we use the class name human dot count. For instance variables, then instance variable. Now for instance variable, okay, we use self dot name equal to name. So this we have done. Created. I have created an object, and here we will write p1 dot name. So it will give me Arsenal. Now if I write here p2 dot p2, we have to create p2 is equal to human, and let's say I give some other name. Maybe let's say I'm giving here mine, for example. So now if I write here p1 dot name, it will give me Harshil. P2 dot name will give me mine. So here you can see that instance variables are getting changed with respect to instances also. P1 is a different instance, P2 is a different instance, and both of them data is different. We can keep same also, but most of the cases we keep them separate, obviously. Okay, there is no point of saving the same data in two objects. Okay, first thing. Second thing here is thus the class variables. Class variables are still going to be same for each and every object, no matter what. Okay. So yeah, that is it. Okay, so let's continue. Okay, so I have already covered one thing I have already explained to you, abstraction. Okay, there are four concepts that we need to cover. Abstraction is there, inheritance is there, encapsulation is there, and polymorphism is there. These four topics we need to cover. Class variables, instance variables, objects, classes, instances. All of you have already understood them. Methods, class method also you have already understood. Let's cover inheritance now. Suppose class, this is a human class, human class is there that we have already created. Now I'm going to create another class called as employee class. Let's say class employee. Now here you can see class that employee is also okay. Here you can see class employee is also a human. The employee of a company is also a human. So what we can do, what we are going to do here, we are going to do inheritance. That means the employee class is going to inherit everything from the human class. Okay, just like we inherit from our parents, same thing happens here also. The employee class is going to inherit everything from the human class, and for doing that you have to mention in the bracket here, in the parenthesis here, human, while creating the class. Here you can see we have not mentioned anything while creating the class. Here we have to mention human because the employee class is inheriting from the human class. Okay, let's say def work. Okay, employee class, employee can work. Okay, for example, self colon print I can. Now let me show one thing class. Suppose I'm creating this human, I'm creating employee class. Done. Okay. Now I will create an object here. Let's say A1 is equal to. So if I write here A1 dot work, can work. But here you can see that your walk and run are basically methods of human class. Okay, and E1 is object of employee class. Two different classes. Okay, so if I write here E1 dot walk, it will throw an error that walk employee class has no attribute walk. Okay, because walk is not there in the employee class, walk is there in the human class so far. But let's say if I write here, if I do the inheritance, so here you can see E1 equal to human. Okay. Okay, so here you can see I am going to create its own init method also. Or let me show one concept. See here you can see class it is throwing an error that init missing one required position argument. Why? Because what happens in case of inheritance, whatever methods are there in the parent class will also become a part of the child class also. Here employee is a child class, human is a parent class. So all the methods, your init method, walk method and run method, all of them will become part of your employee class also, without mentioning them explicitly, because they are inherited. Also the class variables will also become a part here of your employee class. Now class, here you can see one thing. Because employee class does not has its own constructor. Init is constructor, right? So there is no constructor of the employee class. That is why it is expecting one argument, because here one argument was needed. Okay, but let's suppose employee class has their own constructor. We'll write a def init else print by created. This code here you can see if I run this code now you can see it is working fine. Why? Because there is a concept called as, this concept is called as class method overriding. Because you can see the same method, your init method is present here also, in the child class also, in the parent class also, in both the places. So what happens if the same method is present in the child class also, parent class also? So the method of the child class will override the method of the parent class. Between the two, the method of the child class will be always preferred. That is why it is not asking for name. Here we have to enter the name. Here it is not asking for name anywhere, because it is taking this constructor, not the human class constructor. Okay, so this is called as method overriding. I can work. Okay, earlier you can see even.walk was not working, but since the employee has inherited all the methods, that means your walk also and run also, that means your employee can walk also. Walk too. Simply your variables also inherited. See here C and count, both of them also inherited. So if I write here E1 dot here C, it is the, see in employee class there is your here C variable is not there, but it is there in the human class, and it has been inherited by the employee class. So this is called as inheritance. Okay, let's continue. Next is your encapsulation. Encapsulation class, let us understand that first. Okay, now I'm just removing all these things. I'm just showing you one thing. I'm just simplifying the code right now. Okay, I'm creating a variable, one more variable here. Let's say d is equal to 34. Now I will write here underscore d. So what will happen class, whenever we put underscore 2 times, underscore basically before any variable, any class variable or before any method, so that particular variable or that particular method will become private to that class. Okay, here you can see that here C and count, both of them are public class variables. Public class variables are those variables which can be accessed inside the class also, outside the class also. And here your underscore d, since underscore is present twice, it will become private class variable. Private class variables are those variables which can be accessed inside the class only. Outside the class, they does not even exist. Okay, I can run, and let's say I will print here human dot underscore underscore d. For now, it's done. I will create a human. H1 is equal to human. Okay, human created. Now, if I write here class h1 dot here C, working fine. If I write here h1 dot underscore underscore d, it will throw an error. See, it is basically completely ignoring that there is no variable called as underscore underscore d. Even if I write simply d, that then also it will throw an error, because here you can see d is private to that particular class only. Outside the class, it does not even exist. But if I call the run method, if I write here h1 dot run, okay, so here you can see it is printing 34. Okay, so how it happened in h1 dot run? See, how it happened in h1 dot run? Because when we call this method, so your code came inside the code literally came inside the class and ran this method. So I can run 34. So here it is able to access. Why? Because it is present inside the class, because we are accessing it from inside the class, but outside the class it does not even exist. So this is called as encapsulation, because we are securing some data from the outside. See, abstraction is selecting data from a larger pool to show only the relevant details of the object. Inheritance is a process that allows the child object to acquire all the properties and behaviors of the parent object. Encapsulation is hiding the private details of a class from other objects. Okay, simply we have covered these three things. Next is your polymorphism. So let us see this class. Polymorphism says a concept of using common operation in different ways for different data input. Okay, same operation is going to work in different manners for different data input. For example, I am going to create a class first, quickly. Class parrot, let's say, for now. Elf. I'm going to create another class, let's say penguin. F. Fly again. You can see same method is present here also, self, but in this case we can print here print I can't fly. Okay, now we are creating a function class def test maybe. Okay, we are going to pass bird here, and here bird dot fly. Let me explain. Here you can see class, we have created two classes having same methods, fly and fly both, but those methods are different. Name is same, okay, but inside the method you can see they are different. There it is printing something else, here it is printing something else, entirely different methods with the same name in two different classes. And we have created a function right here class outside the class, okay, and that particular function is calling that method. That particular function is going to call that method. Now suppose I am creating a object, let's say, of the parrot class. Okay, let's say I'm writing here paro is equal to parrot. Paro can fly, paro dot fly will work. See, I will create an object of the penguin class. Peggy is equal to penguin. Okay, so if I write here Peggy dot fly, this is, so far we have not implemented polymorphism. Now what I am going to do, I am going to call the test method. I will write a test and I will give paro to it. So you can see it is printing I can fly, and when I give Peggy to it, it is printing I can't fly because of simply this thing, right? Paro is becoming Paro is going to bird, and it becomes Paro.fly. Paro.fly is I can fly. When we give Peggy, so it will become Peggy.fly. Peggy means I can't fly. But polymorphism is here class. This is a polymorphism. You can see the same function is giving two different outputs for two different inputs. Okay, same function giving two different outputs for two different inputs. This is called as polymorphism. Okay, and that is all about your OOPs that we needed to cover. Okay, there are a lot more is there. Okay, according to the course, this is your OOPs. Is there any doubt in there in anything that we have covered class today? We have covered today user defined modules. Then I guess we have covered file handling. Okay, and we have covered OOPs. These three topics we have covered. Any doubt in anything that we have covered today? Anyone class?